In September 2001, construction began on the highly complex VIT plant, the federal government's largest engineering and construction effort that will, when complete, immobilize Hanford's millions of gallons of radioactive waste. Spanning 65 acres, the plant includes 4 major nuclear facilities: pre-treatment, high-level waste vitrification, low-activity waste vitrification, and the analytical laboratory, as well as 20 support facilities and extensive underground utilities. We now celebrate reaching 50% complete on this important facility. 196,000 cubic yards of concrete, enough to fill nearly 60 Olympic-sized pools, have been placed, more than 60 miles of piping, and 14,000 tons of structural steel, the same amount used to build the Eiffel Tower, have been installed at this massive plant. Our team of more than 3,000 includes skilled crafts, experts, and suppliers from around the globe who are committed to working safely. We are the largest construction site ever to strive for the DOE's Voluntary Protection Program star. Our safety program and culture are remarkable for the construction industry, and we are constantly improving. Our team is working to achieve our goal of 0 injuries and make the VIT plant the safest of all construction sites. Working with our regulators, we are also ensuring the plant will operate safely, protecting the public and the environment. The pre-treatment building will be the world's largest and most technologically complex nuclear chemical separations facility. Most visible is the civil and structural progress. Currently more than half of its final height, it now stands 77 feet tall. Huge stainless steel vessels are in place to receive and process the liquid waste. Behind the scenes, we've completed design work to confirm the facility could withstand severe earthquakes. Our research and technology program has verified new applications of advanced technologies to separate wastes into high and low radioactive components. A complicated maze of thick, steel-reinforced concrete floors and walls, the high-level waste vitrification facility will house 2 90-ton melters to turn radioactive waste into glass. Skilled craft workers continue to erect the structures that will accommodate the vessels, piping, and air handling systems to support the vitrification process. The furthest along of our major buildings, the low-activity waste vitrification facility is structurally complete, and work now continues on its internal systems. 2 300-ton melters will produce 30 tons of glass per day. The 130-foot, 125-ton stack assembly topping off the LAW ensures compliance with strict regulatory air emission standards. Integral to the vitrification process, the analytical laboratory features 14 hot cells that, during operations, will process 10,000 samples each year to ensure that the vitrified waste will be safe for long-term storage. Now fully enclosed, specialized air filtration systems and equipment are being installed. The balance of facilities provides all necessary systems to support vitrification. Some of these systems are already in final testing and startup phases. We have made great strides on this vital project since breaking ground in 2001 and faced many challenges. From engineering to construction, we have addressed technical, workforce, and supplier issues to design, fabricate, and build a plant that meets the most rigorous nuclear safety and quality standards. 20 years have passed since the nation's last nuclear facility was built. resulting in a seriously depleted nuclear infrastructure. To reinvent that infrastructure, we are cultivating a new generation of employees who work to stringent nuclear standards. By retooling and reestablishing nuclear quality fabrication shops, we are bringing new life to the nuclear supply chain. To guarantee nuclear quality for all VIT plant materials and equipment, our rigorous supplier inspection process includes 270 inspection assignments in 29 states and 5 countries. To ensure success for WTP operations, our robust research program has resolved major technical challenges for treating Hanford's unique liquid waste. The WTP team constructed the world's largest testing platform and used world-class scientists to confirm our separations processing technology. The pre-treatment engineering platform is a quarter-scale model of the pre-treatment process. The M3 mixing platform is helping us demonstrate the long-term effectiveness of pulse jet mixing technologies for nuclear waste. These testing facilities also provide valuable training experience for commissioning and operations. Tests were also conducted on the HLW canister to confirm a new design that will result in fewer canisters needed. The waste treatment plant will provide a safe, efficient, and proven means to immobilize Hanford's millions of gallons of tank waste. As the cornerstone of Hanford cleanup, the project is pivotal to the future of the Columbia River and the Pacific Northwest. The Department of Energy is committed to this historic effort. Many of the challenges being overcome at the waste treatment plant have never been accomplished anywhere in the world. Our employees continue to safely advance this unprecedented engineering, construction, and environmental solution. We are halfway complete on this mega project. At the VIT plant, we are taking pride and making history.